Okay, still finishing our part 1 problem 1D, cosine of theta over 2. So first thing I'm going to do is cosine of the half angles. Cosine of theta over 2 by our formula is plus or minus the square root of 1 plus cosine theta divided by 2. Which it's very similar. So what was our sine of theta? 1 minus cosine of theta divided by 2. So we could think it's going to be close to a similar answer. But let's see how that works out. So we'll have plus or minus 1 plus, what did we say cosine of theta was in the previous problem? Let's just jump back there. Cosine of theta was going to be square root of 15 over 8. So that's what we calculated using a previous calculation. So let's do square root of 15 over 8. Leave our denominator alone. The next thing we did is we simplified the numerator only by getting a common denominator here. So a common denominator of 8 would be 8 plus the square root of 15. Then of course that's divided by 2. And to simplify so that we're not working with a fraction within a fraction, we're going to multiply this by the reciprocal. So whatever you do to the denominator, you do to the numerator as well, and that's going to simplify for us. And we'll have plus or minus in the numerator, 1 times the numerator is just going to be that same thing, 1 plus the square root of 15. The denominator is going to be 8 times 2, which is 16, and our next step was to simplify our radical. Well, the square root of 8 doesn't necessarily have a perfect square, so neither the square root of 15, so we leave these two alone, but the square root of 16 will simplify. So what's the square root of 16? 4, but that, remember, that's in the denominator, so my 4 is in the denominator, and I pull that out. Okay, the other thing is we are talking about the cosine of theta over 2. Which quadrant is this theta over 2 in? We said it was in quadrant 1, so is it positive or negative? Is cosine positive or negative there? Positive, so it's just going to be positive 1/4 and that's going to be it for that first problem. Okay, so let's see another example like this. This time they're going to give us tangent theta and we're going to be in a different quadrant. Okay, but we want to find all 4 parts. So double angle for sine and cosine, half angle for sine and cosine as well. So the first thing we got to do is figure out which quadrant this is going to be in. So let's do that work over here. So it's between pi and 3 pi over 2. So which quadrant does that tell me we're in? Good, quadrant 3. So I'm going to draw a representative triangle there. And now my tangent theta is defined to be what? It's the sine over the cosine, or what about in terms of x and y? It's your y value divided by your x value. So if I know that that was given to me in my problem as 4/5, then I know my y is a 4 and my x is a 5. But if it's in quadrant 3, on a number line, when I go from here to here, what's that going to be? A -5. And what about if I'm here and I go down? -4. So this gives us our values, but we have to use the quadrant to take into account for our signs of those. Now, I have a missing side. How do we always find a missing side? Pythagorean theorem. Good. So you know the process by now. Okay, so hopefully after you check your work, we've done this many times by now, so we get plus or minus the square root of 41. So I'm going to come over here and put the square root of 41 there. Okay, now we are trying to calculate the sine of 2 theta, the cosine of 2 theta, first of all, so let me go back to those formulas. Here, what two things do I need to calculate sine of 2 theta? The sine of theta and the cosine of theta. So I'll need this information. And down here, I will also need to solve for the cosine of theta. So it's clear that we need to determine the sine of theta and the cosine of theta to be able to work. Actually, let me put it in red so it stands out to us because we'll come back to this page and pull this information. So sine of theta is defined to be what? Your y value over your radius. So our y value in this case is -4 and our radius is square root of 41. Okay, so we're going to use that information. We will also need our cosine of theta, which is going to be your x value over your radius, so that's -5 over the square root of 41. We will use these two pieces of information in each of these formulas to calculate our solutions. So let's go work on the sine of 2 theta first. That's defined to be sine 2 times the sine of theta times the cosine of theta. From your formula sheet, you can pull that. Okay, so we have 2. We're going to plug in our values. What did we get on the previous page for the sine of theta? -4 over the square root of 41, I believe. And for cosine, we had -5 over the square root of 41. Okay. We can go ahead and calculate that. So in the numerator, this is like 2 over 1 if it helps you. 2 times 4 is 8. 8 times 5 is 40. Now, what's a negative times a negative? Positive, good. So we'll still with the sign. Now, what happens when you multiply a square root times a square root? Yes, they're just going to simplify to just 41. So sine of 2 theta, that actually worked out fairly nice, so we like that. All right, let's see if we can fit cosine of 2 theta on this same page. Cosine of 2 theta. We have some options here. Let me go back to that formula page. Okay, we could use any of these. Right, we already calculated sine, calculated cosine. What was given to us was tangent, so we had to use any calculation. I'm just going to use the first one for the sake of just you seeing something different, and we'll go with this first one. So put that on your page and go ahead and start trying that. Okay, so now we're ready to just plug in for cosine squared minus sine squared, and just like we did previously, pulling from our calculations on the last, cosine was -5 over square root of 41, and the sine was -4 over square root of 41. What happens when you square -5? That means a -5 times a -5, which is a positive 25. What happens when you square a square root? Right, you're just going to simplify to 41. Good. Okay, let's move to this one. -4 squared. That means -4 times -4 is a positive 16. And then same thing happens in the denominator. So basically all we have to do is simplify this fraction, and they have a common denominator, so that's nice. So it just simplifies to 9 over 41, and this is our cosine of 2 theta.